Welcome to qnawire.
In this problem, we are learning how derivatives affect the shape of a graph. So more specifically, we're looking at the first and second derivative to determine intervals of increase and decrease and concavity. Now you might be asking, why do we learn this? Well, this tells us a lot of information about the behavior of our function, but also this is a precursor to curve sketching, which is a huge part of calculus. So this will help you understand curve sketching later on in your class. So for part A, we're told, well, let's find the intervals of increase and decrease. The first thing that we need to do is find the derivative. So we're given f of x is negative 2x cubed plus 3x squared plus 36x. Well, we can simply use the power rule to differentiate it. So f prime of x is negative 6x squared plus 6x plus 36. Then to find critical numbers, we set our derivative equal to 0 and solve for x. So 0 will be equivalent to negative 6x squared plus 6x plus 36. So we can factor out a negative 6, get negative 6 times the quantity, x squared minus x minus 6, and then this looks like a quadratic we know how to factor. So we'd get negative 6 times x minus 3 times x plus 2, and then we can just solve for x. Remember, this is equivalent to 0. So x would be negative 2 and x would be 3. And then we can use this information to find the intervals of increase and decrease. The domain of this function is negative infinity to infinity, so all real numbers. So then what we're going to do is we're going to take the intervals within our domain and then determine if our function is increasing or decreasing in that interval. So for the interval negative infinity to negative 2, our function is decreasing. Now, if you are confused on how I determine that, all you have to do is pick a number in the interval and plug it into the function and see if you get a positive or negative result. The second interval would be negative 2 to 3. We see an increasing function there. And then 3 to infinity, and our function is decreasing there. And now for part B, we're told, let's find the maxes and mins of this function. Well, we solved for x. X was negative 2 to 3. So let's just plug those into our function. F of negative 2 is negative 44. F of 3 is 81. So clearly we see a minimum at x equals negative 2 and a maximum at x equals 3. For part C, we're told, let's determine concavity. Well, when you hear the word concavity, your mind should immediately go to second derivative. We need the second derivative test to determine concavity. So let's solve for f double prime. F double prime of x is 6 minus 12x. Again, we'll set that equal to 0 to find the critical numbers. In this case, we only get 1, x equals 1/2. So then what we can do is we can pick two numbers within our interval and test for their sign. So f double prime of 0 equals 6, and that is greater than 0. F double prime of 1 is negative 6, and that's less than 0. So what does that mean? That means we see a concave up behavior from the interval negative infinity to 1/2, and a concave down behavior from 1/2 to infinity. And then because we switch from concave up to concave down, we have an inflection point at x equals 1/2. And finally for D, it says, let's check the graph of this function and see what we got was correct. So this is the graph of the function, and you can see that our intervals of concavity and increase and decrease are correct. And you can also go through this more specifically and determine the points as well. So I hope this problem helped you understand a little bit more about how the derivative can affect the shape of a graph, more specifically how we use the first and second derivative test to determine things like critical numbers, intervals of increase and decrease, and the concavity of a function.